So let's predict the chemical shifts for this molecule. So I marked the hydrogens on the molecule, and it turns out that there are 5 different types. These 3 and these 3 are identical. This would be the second, the third, the fourth, and the fifth. We have a carbonyl group here. This carbon is alpha to the carbonyl group, and this one is beta to the carbonyl group. This one is also alpha to the carbonyl group and beta to the carbonyl group. I'm going to change colors to the orange, and then we'll look at the ether. Group number 4 is alpha to the ether, and group number 3 is beta to the ether, and group number 5 is alpha to the ether. Okay, so let's look at group number 1. Group number 1 starts as a methyl group, and so we'll start it at 1.9. We then say that it's beta to a carbonyl, and so it's 0.2 to give us, we expect it to show up around 1.1. If we look at number 2, it's a methionine protein, and so it starts as 1.7. It is alpha to the carbonyl group, and so it's a 1.1, and we get 2.7. Group number 3, these are methylene protons, and so they're 1.2. They're going to be alpha to the carbonyl, so that'll be 0.1 added to it, and they're beta to that oxygen, so we add 0.5 and get 2.7. The protons at position 4, these are also methylene protons, so we start with 1.2. They are alpha to the oxygen, gives them 2.5, plus they are beta to the carbonyl, and so we end up with 3.9. The protons at the 5th position are methyl and so they are alpha to the oxygen, so they start at 0.9, alpha to the oxygens, that's plus 2.5, and that gives us 3.4. So these next ones, I'd like you to try and do them on your own and then run the rest of the video. We'll start with the protons at the 1st position. These are methyl protons, so we start at 0.9. They are beta to the aldehyde group, and so it's 0.2. We expect to see that at 1.1. The ones at the 2nd position, these are methylene, so they start at 1.2. They are alpha to that aldehyde group, that same aldehyde group, and so they're 2.2. The protons at the 3rd position, also methyl protons, so they start at 1.2. They are alpha to an ester group, so they get a bump and end up at a bump of 3, and so they end up downshifted to 4.2. The ones at the 4th position, also methylene protons, so they're 1.2, and they are beta to that same ester group. So that's 1.6, give us 1.8. The protons at the 5th position are gamma to that ester group, and so there's no effect. And they're methyl protons, so they're at we expect to see them at 0.9. So let's look at this next one. So let's look at our B compound here. There are only 3 different types of protons on this molecule. The ones at the 1 position are methylene, so they start at 1.2. They are alpha to an aldehyde that's up here at the very top, so that's +1. They are also alpha to the orange ether, and so that's 2.5, and we'll expect to see the peak at 4.7. The protons at the 2nd position are methylene, so they start at 1.2. They are alpha to the orange ether, so that's 2.5, and they are beta to the ester that I've drawn in pink, so that's 0.6, 4.3. The carbons at the 3rd position are methyl, so they start at 0.9, and they are beta to the pink ester that I drew, so 0.6, and we'll expect to see them downshifted to 1.5. C has 4 unique proton types. The first is methyl, so it's 0.9. It is alpha to an aldehyde, so that's +1, and that gives us 1.9. The second one is methylene, and so it's 1.2. And then it's alpha to the aldehyde, so that gives it a 1, and we'll expect to see that one at 2.2. The third type is this one that's right here. It is got just 1 hydrogen at that position, and so it's a 1.7. It is beta to that aldehyde group, so we add 0.2, and we get 1.9. The 4th position is gamma to the aldehyde. That's too far away for it to have any effect, and so it stays at 1.9. When we have a conjugated ring, an aromatic ring, we have hydrogens off of it, there's a lot of deshielding of these hydrogens. There's an induced magnetic field, and these protons are all deshielded by it. So they are downshifted significantly. And when you have an aromatic ring, you'll see protons downshifted. These are past 7. And you'll see multiple peaks like that because they interfere with each other. Okay, so now there are other types of proton chemical shifts. We've already talked about the methyl, the methylene, and the methylene, 0.9, 1.3, and 1.7. Let me, so that I can point. Okay, 1.9, 3, 1.7. There's an allylic, which means that it is, this is the double bond between here and here. It's a hydrogen attached to one away. That'd be allylic. And so we could look through these. We've got an alcohol, a vinylic. We've got one off a conjugated ring. We have an aldehyde that is shifted way down, and a carboxylic acid that's shifted even the farthest down. So for each of these compounds, we can identify the expected chemical shift. So here I've redrawn B so that I could draw in all the hydrogens. We've got 5 unique types of hydrogens. So the hydrogens at the first position are allylic. And that is because this carbon is 1 away from the double bond. Allylic hydrogens are going to be at about 2. The hydrogens at position 2 are vinylic. Because they are attached to the carbon that is part of that double bond. And we expect those hydrogens to be between 4.5 and 6.5. I'm just getting those off the table. The hydrogens at the third position are also allylic. They are 1 away from that double bond. So we expect them to be around 2. But they are also beta to the oxygen. This oxygen right here, these are alpha. This carbon here is beta to those oxygens. And so we expect to add 0.5. We get peak should appear around 2.5. The ones 4, these are methylenes, and we've been using 1.2 for that. They are alpha to this oxygen, which adds 2.5 and gives us 3.7 as our answer. 5 is this hydrogen that's attached to the oxygen. From our table, we see that that should be between 2 and 5. It's a pretty big range. But I'm just reading that off the table that's right up here. Alcohol. And I also got the vinylic here, and I got the acrylic there. Okay, so let's look at C. I'm going to draw it really big here. We've got hydrogens here, 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 here. There are none here, but there's some here. So we've got 6 different places we've got hydrogen. 1, these are allylic, so we'd expect this to be about 2. The second ones are methylene, so they'll be at 1.2. I'm getting that from right here. 3, same deal. 4, though, these are allylic to the double bond. 1 away. Here's a double bond. We are 1 away from that double bond, and so we're allylic, and we expect to see that around 2. The ones on at the 5 position are vinylic, and we expect to see that between 4.5 and 6.5. The ones that are at 6, we are allylic there, so about 2. Okay. That just leaves us with